Hello everyone. Today's session I'm going to talk about what is the difference between HashMap and HashTable. So first of all, going to the depth of the things, just I want to highlight some key points. What are the differences between these two? Okay. Yeah. So in this table, I have highlighted a few points where you can see the differences, the major and quick kind of highlight points that I have listed here. The first difference is no method synchronization. In hash map, none of this method are synchronized. It's all like a not thread safe. Okay. And whereas the hash table, it's every method is synchronized and it's a thread safe kind of environment. And it's not preferred to use for multi-threading coding. The point two, which I have mentioned, is the multi-threading can operation simultaneously. Hence, this hash map object is not thread safe, right? So the same point, like here, it's a synchronized, so it is recommended to use for multi-threading code. At a time, one thread is allowed to. That is also the limit we have, right? If one try to update some value, other thread needs to wait. So that's the reason. The third point is the performance is more because it's not synchronized. Hence, the performance is high, but it is synchronized. So obviously, when there is multiple threads, it's trying to more add some data and do some operation. Obviously, it takes the time because it is trying to allowing multiple thread to do the operation, right? So the waiting time will be there. So hence this performance is very low. And the data, like you can't have any null key. I mean, it allows null key one, null key, and multiple null values. But hence this hash table doesn't allow any null key or null values. Okay. And hash map introduced in 1.2 version, and hash table introduced in 1.0 version. And this is not a legacy, and this is a legacy class. So this is the very high level key points where when anyone is asking you the difference between hash map and hash table, right? So next thing, just I want to highlight you on the give me a minute. Yeah, sure. Okay. So little bit giving you the little bit internal implementation, how it's storing the data into the uh, data structure, right? So here I have added some three elements to the hash or map object. Just have for quick reference, just imagine this hash map is nothing but an instant of hash map instant. So where I have put this data, basically this is trying to push the data to the list. So when this line of code is performing, right? So what happens? The key this converting to a hash code. Hash code we all aware, right? It's an integer. So integer, like when you convert this as code, then it gives us some four or five integer. I mean, it's a kind of some uh, numbers, right? 6-digit numbers. So post getting this hash code, we are shifting it and minus n minus bucket length minus one. Right? This is n, then nothing but the bucket length. Like by default, HashMap allows 16 buckets. Basically, each bucket has the type of linked list data type. Internally stores the key value, right? Okay, we are good. Correct. So now I'm adding the first element to that object. So what it tries to convert, get the hash code, and it'll do the shifting, and it'll try to find the index of the bucket. So my first case, what happens? It giving me the index. Imagine it's giving the index of one. So what I'm trying to do, I mean, internally what it does, it will try to push the element to the bucket, index bucket one, right? So in index bucket, again, each bucket has the linked list structure, right? So the linked list structure for each element has the type of this three properties, like it contains the hash uh, value, key value, and node. it will tell us what is your next connected node, right? Like that, it will structured in linear data structure basically. So first element will be added here, and the next Rajesh, again it will convert it into uh, yeah, I guess I hope this will be zoomed. Oh, sorry. Yeah. Okay, this is fine. So the next element I'm going to add Rajesh and Sharma's value, right? So this Rajesh, when I do this hash key, okay, hash code conversion, it gives me 25351. Okay, so based if I converted this to index, finding the index value, then what it does, it will try to convert this integer and giving the index. This index will try to find the bucket. From the bucket, it will try to check whether is there any element is present. From that element, it will try to add it to the next, create a new node, and that node will point to the previous one. That is the key. And this next will be null. Okay. So likewise, it will add one by one to the list, linked list. So here the another picture representation how the key values are stored. Right? Okay, so there is one more important concept in the hash table, like the hash collisioning, right? When there is same hash code, for example, here Rajesh and Rakesh, this both uh, um, keys are giving the same hash code value, like say 525351. So this is what the hash collisioning will happen. So first condition, it will check for hash code, and then it will go into the say the bucket index, and from bucket it will try to perform the equals object equals. If the object is equals, it will replace the uh, data into that list, right? So that specific node actually. So if the data is not equal, then it will create one more node and it will point to that node. That's how it will creates the nodes. Likewise, it will create. So so far like this same concept is applicable for both hash table and hash map. Uh, Yeah, so I hope this video helps you to understand like what is the major difference between these two objects. I mean these two classes. And yeah, thanks for watching. I'll see you. I'll catch you in next video. Thank you.